In this video, we're going to quickly go over combustion reactions. Now, combustion reactions are almost all exothermic, so they give off heat. They produce the common oxide, and they use oxygen gas. So if we have the combustion of a metal, it'll be the reaction of the metal with the oxygen. And if you consult your data booklet, you'll find that iron 3 is the most common ion. So it's going to make iron 3 oxide. And so it's going to be Fe2O3 solid because it's an ionic compound. And to balance my oxygens, I need 3 of these and 2 of these. This makes 4 irons. So now it's a balanced combustion reaction of iron. This is exactly the same for metals as formation reactions, but it's the formation of the metal oxide. For molecular compounds and nonmetals, anything that has nonmetals, the combustion still uses oxygen. So in this case, I've got, this is chemicals called butane, reacts with oxygen to produce the common oxide of carbon and hydrogen. So the carbon reacts with oxygen, hydrogen reacts with oxygen, and carbon's common oxide is carbon dioxide gas. Nitrogen's is a nitrogen dioxide gas. Sulfur is a sulfur dioxide gas. So those are easy to remember because they're all dioxides. Water is pretty easy to remember. Hydrogen's common oxide is water, but it'll be a gas because these combustions are happening at high temperature. So my carbon becomes carbon dioxide gas, and my hydrogen reacting with the oxygen produces water vapor, so H2O gas. I have 4 carbons, I have 10 hydrogens, I have 2 oxygens, 1 carbon, 2 oxygens, 2 hydrogens, and 1 oxygen. So it's easy. These are actually pretty easy to balance with the exception sometimes of oxygen. So my carbons, to make them equal, I put a 4 here. And that leaves me with 8 oxygens here. Plus, I have to balance my hydrogens. So 10. So this is a 5. 5 times 2 is 10. But then I also get 5 times 1, which is 5. So I have 8 plus 5 oxygens for 13 oxygens. Now, the problem is I can't make this nicely into 13. If it was 14, I'd multiply by 7. If it was 12, I'd multiply by 6. But 13, I'd need to multiply by 6.5. That's not allowed. But fortunately, if I want 13 of these, 13 over 2 times 2 gives me 13. So if I get an odd number here, I just put it over 2 and that's my fraction. If I wanted to get rid of the fraction, I need to multiply everything in this reaction by 2. So I would have 2 butanes, 13 oxygens, 8 carbon dioxides, and 10 waters. And those would be the coefficients here. So I'd have 2 moles of this, 13 moles of this, 8 moles of this, and 10 moles of this. But I am totally okay with oxygen being balanced with a fraction over 2.